Hey there. Welcome to our practice set for special cases. This is special cases of multiplying binomials. Please like and subscribe if you find this video helpful and drop a comment or ask a question below. As always, pause the video to work these problems on your own and then come back to check your work. Okay, so we're gonna do these in kind of like groups. I tried to scatter them around like the different kinds of things you might look at. So first one is the x plus 1 times x minus 1. And if you watch the lesson, you know that these are called conjugates. And when you multiply conjugates, the middle terms drop out. And so you got two options for doing this. You can set it up on your area model, or if you're using foiling or some other method, you can go through the work. So x times x is x squared, 1 times x is x, 1 times negative 1 times x is negative x, and 1 times negative 1 is negative 1. And I apologize. Again, I haven't got my important phone call yet, so just having to put up with that. Okay, and x minus x is 0, right there, leaving you with x squared minus 1. Now, looking at the next one, we have x minus 7 times x plus 7. You might find that it's faster to do this without using the model or doing the foiling, because you've got x times x, that'll be in that upper left box, and then you've got the lower right box, and those are the only two boxes that you need to think about. So x times x would give you x squared, and then negative 7 times 7 would give you negative 49, and you don't need to do the other two boxes, okay? But if you feel like you're going to forget about those other boxes, like if it's not the conjugates, that you know what, do them anyway. Now for 3 and 4, I actually put these in here just to draw a bit of a contrast between these and the conjugates, just so we can see. That's why I kept the number 7 in there. And if you watch the video lesson, I do go over what the formula for this is, but I personally would not recommend using a formula for these problems. We have x squared, x times 7 is 7x. This will match. It'll be also another 7x. And then 7 times 7 is 49. And so this will be x squared, and then combine those, and it'll always be double. That's part of the pattern that you'll see there. It'll always be double. So 7 plus 7 is 14, and there's your 49. And notice too that it is not the same. Okay, it does matter whether you have minus and plus, or two pluses or two minuses. Yeah, it does matter. All right, the next one has the subtraction. So we'll take a look at the subtraction. And I do strongly recommend that you write that piece of it out, because yeah, it'll just remind you that you're not going to try to distribute an exponent in there at all. So we have x minus 7 times x minus 7. So x times x is x squared. This will give us negative 7x this time in both places. And then negative 7 times negative 7 is also positive 49. And so you might notice that the last one that we did was x squared plus 14x plus 49. And this one is x squared minus 14x plus 49. So again, some patterns there that you can exploit if you are observant. 5 and 6 go back to the difference of squares. So these are going to come out being the difference of squares because we're multiplying conjugates. And I'll go ahead and do one of these on the area model just so we can get practice with both. 3 times 3 is 9, and x times x is x squared. So 3x times 3x is 9x squared. Here we'll have 21x, but here we will have negative 21x. That will always happen with your difference of squares. And then positive 7 times negative 7 is negative 49. And so our middle terms cancel out, leaving us with 9x squared minus 49. And for this last one, I'll go ahead. This is 5x minus 1 and 5x plus 1. And again, it doesn't matter which order the plus and minus are in. Okay, is just if they're conjugates, they're conjugates. And you might be able to do this faster without busting out the area model, because we will have 5x times 5x. That'll be that upper left-hand box. So that'll be 25x squared. And then we need the lower right box, and that'll be the -1 times 1, which would be -1 or -1. And you are welcome to put that onto the area model. It's certainly not wrong if you did, or if your teacher is using like the FOIL method and you're doing first, outer, inner, last, also fine. Okay, what's important is that you understand the way that you're doing it and are comfortable with that. All right, we have one more of this type. So let's look at number 7. So 6x plus 5 all squared. So remember that is 6x plus 5 times 6x plus 5. Do not tell me it is 36x squared plus 25. Okay, you will be missing something very important if that is the answer that you have. So we have 6x plus 5 and 6x plus 5. So this is the 36x squared, okay? So 6 times 6 is 36, and then the x times x is x squared. But right here, we have 30x, 6x times 5 is 30x, and then we have another 30x. And now here's where the 25 is. And then combining our middle terms, we have 36x squared plus 60x plus 25. So if you try to distribute, and distribute isn't even what's happening there, it doesn't even meet the definition of distributing. But if you try to do that, you could get the 36x squared plus 25, but you'll be missing the 60x, and that is absolutely important. That is not like some negotiable piece of the puzzle there. Now for 8, 9, and 10, it was what were the factors? And you've got a couple ways to do this. Some of you might be able to just look at it and you're just like, I see it. I see what it should be. Some of you might be more comfortable just setting up the area model and saying, okay, well, that had to be an x squared and that had to be the -100. And then you just kind of think to yourself, all right, well, what would have gotten me the x squared? Well, that would be x times x. And then these guys we know ended up canceling out. But we could get the 100 with a 10 and a -10. And so your factors would be x plus 10, x minus 10. And again, you might be, somebody's probably thinking this. You're probably thinking, well, how do I know that it's not positive 50 and -2? How do I know that? Because positive 50 and -2, that would give me the -100. Well, the reason you know it's not positive 50 and -2 is because if it were, you would end up with things that would not cancel out. So if you were to figure out what those middle pieces were, that does not cancel out. So 50x minus 2x would give you 48x, and we did not have that in the original problem. So that's how you know it's not something other than the 10 and the 10, because the 10 and the -10 would cancel out in those middle pieces. So somebody might have been asking that question. Number 9. Now, again, you can try to do this without setting up the boxes and say, all right, so for that upper left-hand box, 9x squared, well, I could get the 9 with a 3 times 3, and I could get the x squared with an x times x, and then one's a plus and one's a minus, and I could get the 25 with a 5 times 5. Okay, and essentially what you're doing is you're taking the square root. Now, that process there, that is called factoring, and it is the next major thing that we cover. So if you were able to just kind of figure that out, because we've got some rules and some structure in place, then you are actually a couple steps ahead at this point. Now, this one was kind of the challenge problem of the set. So this one might be harder to do. So you got the x squared. The x squared had to come from that upper left box, and the 81, if you've done the area model, the 81 comes from the bottom box there. And then you need something that's going to add up to 18. But if you remember from doing a bunch of these, okay, these two boxes are always the same. So you want something that's going to add up to that 18x, but it's got to be two of the same thing. And so you think, okay, well, 18 divided by 2 would give me 9. So 9 should work. Like if I had 9x and 9x. Now notice if you add up all these boxes, you got x squared plus 18x plus 81. So they all add up to what we know we need to have. And then you can figure out, well, what would go here? This could be x times x, and then a 9 times 9 would give me the 81, and then you could just kind of double check 9 times x, 9 times x. Oh, that looks good. So this would be 9 plus x times, x plus 9 times x plus 9, or x plus 9 squared. Now that's actually getting quite a little bit of like further ahead than where we are. So if you struggled with that, that's okay. If you made any kind of progress with that, you're doing well. And if you got it, then you are just incredibly well positioned for where we are going to go next with our study of quadratics. So that one definitely was thrown in as a challenge problem. And I always tell my students, I'm not concerned so much about whether you got it right, but whether you attempted it, whether you are giving it your best shot. All right, so please don't forget to like and subscribe for more math content. Ask a question or drop a comment to engage. If there's something we went over in this that you have a follow-up question on, please ask. And check out some of the other content on the channel. We have a channel or a playlist for multiple choice strategies, a whole playlist on how to use Desmos, how to do stuff on Desmos, and some algebra tiles instruction that might come in handy for giving you a more visual way to see what we're covering right now. So be sure to check some of that out, and I will see you in the next one.